Okay guys, welcome back to Codis Arcade. I hope so that I am audible, and welcome back to our live stream. Alright, so good evening everyone, this is Ashank David, and in today's live stream we are going to talk about DSA again, and we will continue from where we left in the yesterday's class. I hope so that I am audible, and if you are having any issues with the audible or the my mic or any camera issue, then please let me know. I'll try to resolve that. And let us continue from where we left. Actually, in DSA we were doing linked list concept, and as we know that we have already, this was the code which we have written here, and till here in this case we have written it till here, where we have created the node class, and we have created the class linked list, where we have taken up the head and we have taken up the constructor, the default constructor, and we have initialized the head into equals to null right now, and then later on we have created up in the same class, we have created up the insert at head function, and then we have already explained you the logic of all that insert at and all of that thing in our previous live session, and we have done insert at tail, and where we have yesterday we have done insert at tail, where we have understood how to do the insertion at the tail, and right here we are trying to, today we will be trying to do the insert at position function. So today we will be seeing this right here. Apart from this, we have a display function that we have already created, because due to which we are able to actually see our output, and these are some of the operations which we have done. So insertion at head check, we have done it, inserted many different things at head, and then we have done insert at tail check, we have also done that. Today we are going to do insert at position, and let us start without any further ado. Let us actually start. So first of all, welcome back to this live stream guys, and I would like to tell you that before I start with this live stream, I would just suggest you to watch our previous live streams also. If this is your first live stream and this is your first time visiting our channel, please do like, share and subscribe to our channel. This is Ashank David, and I usually teach DSA and other stuff on this coding channel. So if you like, share and subscribe to my channel, it would help us to grow in more on YouTube, and share this videos as much as possible for those people who are learning DSA, so that they also can learn DSA. This is all for free, and my motto is to get so many people get placed into the company. Also we are starting to give placements also. So if you are wondering about your placements, if you want a placement or a job, please do let us know, because we are also trying to provide you some placement related stuff as well, where we have some companies getting in touch with us that we can get you into towards the interview. So all of these things are going on right now, and the motto of this main series is to help people understand DSA much more better. And in this live stream, every day I am coming live and doing this. Well, we were on to DSA, and we were on to linked list concept to be exact in DSA, and we were continuing here. So as you have already seen, I have recapped the things that I have done. Now in this case, let's continue. So today we are going to do insert at position. So as you already know, insert at position, and if I show you the linked list. So this is the whiteboard link that I have created for today's class, and I have already taken up the linked list here. There you go, you have the linked list here, and this is what I explained you yesterday. I said that I will be explaining you this in more depth today, and where I have just taken up this example. We have already done the insertion at tail, insertion at head, the insertion at tail, we have already done that, and today we are going to actually see this part, the insertion at a particular position, where I am going to explain you, and this is going to be the insertion end of this particular thing. So let's continue. Let me just hop on to this, and let me try to make you understand how this works. Okay, so the logic I have already explained you before, and I hope so that there is no problem or issues into this. So let us continue from the logic. We are trying to do this. What you are seeing here is insert at position. In insert at position, what we have done is that we broke this link in between, and we tried to insert this link, this node right here into this given linked list. We have already created this linked list, and actual linked list was starting from here to 40, but later on we have added up some this also into the particular linked list. But in this case, we are trying to now insert this particular node in between of this whole linked list. Okay. So that means we are trying to do here what? Insert, let me write it properly. We are trying to do insert at position, insert at a specific position. Okay. This would take up a value, of course, a value, and one more thing, it won't take the head, but it will take the position. Am I correct? So where in the position? I have also given you it as homework, so those people who have done this, that's very good. But now today let us see how we will be doing this. Insert at a particular position inside a linked list. Remember, this is a single linked list, we can only travel into one direction, so we will have to write the code according to that. We have already had inside the particular linked list, so we don't have to worry about passing the reference or anything like that head. We have already created a linked list class and we are doing everything fine from there. The very first thing that you would like to do is, as I told you in the explanation part, I have already told you that if you want to do the insertion right here, okay, like if you want to do insertion right here, what you will do? You will start by creating the temp right here, this temp. Okay, this particular temp, you have this temp. Okay, you will make this temp reach to that particular position where you actually want to input this. Understood a point? So what you will do, you start the temp from the beginning of the head. You start the temp from the beginning of the head, and you will ask the temp to jump into the next node, keep on traveling until it reaches this node. Well, how it will reach that particular node? We need to first understand some of the indexes part. Now, I told you that in linked list indexes concept doesn't support, but I can use the indexes which are coming from 0 basis. That means I am creating an imaginary index. Well, you don't have to explicitly create any variable or anything like that. Imagine that this is your 0th node, this is your 1th node, this is your 3rd node, this is your 4th node, this is your 5th node, this is your 6th node, and so on. If this is the case, then, because you see I have taken the references from 0, why? Because in natural programming, naturally the indexes are taken starting from the 0. Now, in this case, what is happening is that the temp is starting from the 0. If the temp is starting from the 0, I can ask temp reach until you reach the position. So, if the user said, if the value of position is, if the value of this position is, for example, 3, if the value of the position is, for example, 3, in that case, what you will do? You want to insert it right here, correct? Or let us say you want to insert, because in the program it looks like it is inserting at 4. So, let me just take the example of position as 4. This way I do not have to change the whole program again and again. But you saw that, let us say imagine the position is taken as 4. In that case, technically speaking, 0, 1, 2, 0, 1, 2, 3. Yeah, it is actually 3 only. I was wrong. Let us revert it back. I am sorry. I am saying 3. Okay. So, here according to this 0, 1, 2 at this particular place only, imagine. Okay. So, or you can say this. Okay. So, in this case, what you will do is, you will take your temp to 1 less, okay, or at that particular point. And what do you do is, you ask the temp right now, the temp would be connected to this, correct? If imagine this was not the case, imagine this insertion was not the case, and if you wanted to insert it right in the middle, you would have to reach the temp till right here till this node, and once you reach that particular node, what you would do, you would cancel this connection with this connection, and then you would have told that this connection should happen with this connection, correct? That means if this is 2176, then 2176 should be inputted right there. Understood my point? I hope so that this is very much clear. So the temp is reaching where? Temp is reaching where? To this point, and then from there, rather than putting this here, breaking this off and then putting the ends address, if this is n, if this is n, then ends address will be stored here in the temp of next, and the temp of next would be stored into the n of next, as you can see it clearly here being happening. So in this case, this is how you would have done the insertion at tail. It is very simple to do. In this case, what I would do is I would start by creating the temp, okay, but don't forget about the edge cases also. If the head is equals to, if the head is equals to null, that case also you need to check. If the head is null, then there is no linked list present. At that time you should not do anything, but you can do insert at head, you can do that, right? Okay, let us check this condition later on, because there can be multiple edge cases also in terms of this. So what I will do is, I will say let us check only for the main logic first, and I will tell you that there are multiple edge cases, not only just when the head is equals to null, but there are many edge cases in this scenario of insert at position. So let us talk about the edge cases later on. I am not going to confuse you right now. What I am going to say is, as we already discussed, that we will start by creating the node star temp, where the temporary pointer will start from the head. So in this case, we will start from the head. Temp is equals to head. So that means temp will start from the head. After the temp starts from the head, what you need to do is, the question is, how would you reach till that particular point? How would you reach till that particular point? That is my question. And if I want to reach that particular point, what I will do? There can be many different ways. People, you might think that the best way or the easiest way is to take a count variable, right? You can take a count variable and you can keep the count is equals to that particular thing, whatever the position is, and you can just decrement the count while you are doing the job. But I will tell you the best alternative solution for this without any extra variable or auxiliary memory, and that is going to be your while loop itself. The solution is hidden inside the while loop itself. I would just create, I will directly write the code here, I would just create a while loop saying that do minus POS position, or it depends what you want to do actually. I will say position minus. Here we started the use of logical, not logical, but the operators, the unary operators, where I said the first take the position and then decrement it, do the task and then decrement the position, that is post decrement basically, which I am using in unary terms, in unary operator. While minus position, keep on saying temp is equals to temp of next. If I do this, then what happens? You only see for yourself. So I send temp value is what? Let us say position value is given to you as 4, okay. So temp is already started from the here, okay, and now you said that decrement the position, or let us say this is 3. So I said first temp move to the next position, that means this temp reached here, and once this temp reached here, what did you do? You said position minus minus, that means this has become 2. Then I said temp, you move here, and I said position minus minus. Are you getting my point? Like that. Is that clear to you, all of you? Or if the value is too big, like for example in this case the value is becoming too much bigger, and I want my temp to start again from here and reach at the particular point, I would suggest you to do minus minus position, that is pre-decrement position. That means while minus minus position, in this case first we will decrement the position and then our temp will increment to that particular point. Then again we will decrement it by 1, and then we will say you incremented by 1, okay, like this. And then again we would do this, and then we would say decrement or incremented by 1, like this. At that point of time, let us say it was just 2 only. I will do it again. Let us say position is 2. So what you do is decrement it, and then you ask temp, you go to the next. Then you say decrement it, then you ask temp, you move to the next. Now temp has reached here, position cannot decrement anymore. Why? Because even if you try decrementing the position, what will happen? Because this whole thing is written inside while minus minus position as, at some point of time this will become 0, means while loop will stop, and when while loop will stop, what will happen? It will come out of the loop, and when this happens, my temp reaches at that particular position. Initially temp started from here, but we made it reach here in no time, okay. So once you have done this, now your temp is standing right here at this particular place. Now what you need to do is, you started from the head and you reached to that particular position, and once you have reached to that particular position, what you need to do is, now see this diagram here, temp is right now standing here, and you have to also create this node, right? You would have actually created the node before only, okay. Imagine you have already created the node before only. Let me just take the whole reference here. Let us say you have created the node before only. So I said node star n is equals to new node. I have said this, okay. So you have already created the node, and then you have created the temporary node, and then you are saying that you are moving to the particular position, and once you have reached the particular position, now temp has the access to the temp of next. If you zoom in here and see, temp of next is pointing towards that right now, okay. So what you need to do is, you need to change this to the newly created node. That means basically at this place of time you have to say temp, you will point towards n of next, just n, not n of next. You will just say n. Temp you will point towards n, and the n of next. Temp will point towards n, and the n of next will point towards n of next. It will point towards where? It will point towards temp of next of next. Are you getting my point? We can say temp of next, or I can say temp of next. So in this case it will point towards temp of next. Correct? This is the correct logic in this case. So temp will point towards n and n of next will point towards temp of next, because temp of next was this. Are you getting my point? But you have to take care of some things right here very carefully. And what are those? Imagine you have not done the connections yet. If I do temp is equals to n first, if I say temp is equals to n first, right now temp is storing 2, 3, 2, 1, right? Temp is storing what? 2, 3, 2, 1, which is right now this. Correct? Am I correct or not? Okay, right now temp is pointing towards there. Absolutely fine. But then this, you said temp is equals to, basically this would be temp of next. Temp of next would point towards n. And if you said temp of next point towards n, what will happen is that this will get broken and this will get deleted, and what will happen is that this will get connected. So this stored now 2176, but you remember that you have abandoned the rest of the linked list in that case because of that. You understand my point? This thing has been broken. Why it has been broken? Because you have forgotten the 2321. Arey 2321 was stored here. So if you do this step first, you will only do your harm only in your program. Understand my point? Because now the thing is that this n, the n of next doesn't have anything. So how you will connect this n of next with this? How? In that case, you cannot do this first. First what you need to do is this. Number one step is this, that n of next should point towards temp of next. Temp of next was pointing towards 2, 3, 2, 1, which means this was connected to this, and I said that this temp of next is pointing towards here, so n of next should point towards there. So I said n of next should point towards temp of next. Are you getting my point? So in this case, this value is copied here. So technically 2, 3, 2, 1 is stored right here in n of next, and when this happens, this connection is made first. You have secured the rest of the part while remaining connected to the same node. Understood my point? This way you will not lose the later part. You make sure that the new node is connected to the rest of the linked list first, and then you connect that first half of the node to the newly created node, right? After that, on the second point you will do this. This is your first point and that is your second point, where now temp can easily point towards n. That means temp of next can point towards next, n. Okay? So in this case I can store, in this case I can store 2176, which means it has connected to this and this got broken. I hope so that this is very much clear. The logic which I have explained to you is very much clear. Understood? And the node is inserted at that particular position as you wanted. So if I write and continue the code here, after my temp reaches that end position, what I have to do is I will have to say that n of next will point towards temp of next, will point towards temp of next. N of next will point towards temp of next, and the temp of next will point towards n. And when this happens, you have successfully done the insert at position. Well, that is it about insert at position. But the logic and all these things doesn't get over here right yet, guys. The thing is that there can be multiple edge cases in this case. You see, this whole thing which I have explained you, can have a flaw. This will only work, you see, this part, this whole program will only work when our, wait, let me explain. This program will only work when our position is valid. Understood? When our position is valid. It will only work then. What I mean to say is that if someone has entered a right position where the input can be done or the insertion can be done, only at that point you can actually do the, then this code will only work at that particular point of time. I hope so that this is very, very much clear to all of you. If you have any doubts, please do let me know in the chat. I have the chats opened up already. Well, how to solve this issue then? To solve this issue, this is a very big problem. What if someone has entered position as 100, while we have 10 nodes into our linked list, someone has entered position as 100. 100 doesn't even exist. So what we need to do? We need to create another function which calculates the size of the linked list, get size, which will traverse and which would calculate the size of the linked list. And later on, based off of that size, you will check if the position which the user has entered is lesser than the size of the linked list. This is the thing. Not only that, but also and position is lesser than the, position is greater than the 0. These are the two conditions that you need to take care. First of all, position cannot be negative. Position cannot be negative. If position is negative, then that means that you cannot do anything in that particular position, you cannot enter anything or you cannot insert anything. Are you getting my point? Or if the position is even greater than the size of the linked list, at that time also you cannot do any insertion at the linked list. These are the two cases, these are the two conditions that you need to take care of. But how to get this? You need to create the get size. Right here, this is the thing which will save you. This is the thing which can actually save you. I hope so that this is very, very much clear. My question is, how the hell it can save us? So we need to write the code for that as well. To write the code for that, what we will do? Simple traversal. I'll create a int type of get size. This will function get with the size of the linked list. Okay, it is not gonna take any variable as the parameter. because it doesn't have to, it is just going to return the size. That is why I have taken the return type also as int in this case, alright. And inside this I will be creating a variable called as, not variable but a temporary pointer called as node star wait, before I said that, I will say I will create a variable called as int size, which will be initially equals to 0. Okay. Then I will say that, then I will say what? Node star temp start from the head, and while the temp is not equals to null, keep on doing temp is equals to temp of next, and once you reach there, what do? You say return. What do you say? You say return size. But I did not do anything. Before I say return size, I need to say size plus plus. You got it? And then I said return size. This will return the size. Okay. So, ladies and gentlemen, this code will give us the length of the linked list, and once we have got the length of the linked list, the size will tell us the length of the linked list, and once we have the size of this linked list, what we are going to do? We are going to use this to write some if else condition. If position is lesser than greater than 0 or lesser than 0 or position is greater than the size, in that case cout cannot do the insertion. I hope so that this is really clear to what I am writing. Okay? Understood? And else, if what happens if someone enters position is equals to one more condition is there, and that is for 0. This is the second edge case. First edge case is position is lesser than 0, that means position is negative, or the position is greater than the size. In that case we cannot do anything. Or else if position is given as 0, that means you have to do insert at head. If you don't know insert at head, please go ahead and watch our previous to previous live session, we have explained you that there. If you don't have the insert at head option, then you could have said that the insert, then the new node itself will become the head, which means basically doing the head itself. Understand my point? Else if, so here you will do insert at head, you know how to do that. Okay? Else this whole logic will be written inside this else. I hope so that this is really understood and it is very much clear to you, all of you. Understood? That's it for the logic part. Let's code for this and finish this off. Okay? So let us start our code. As you can see here, a lot of things we have done today, and let's go ahead in here and let's write the code for it. Okay? So let us code. What will I do? I will check if the position is lesser than 0 or position is greater than the size. Okay, int val comma int position also it will be there, right? I hope so that this is very much correct what I am trying to say here. In this case you will say cout cannot insert, or I can say here invalid position, and then you say return from there. Or I will not write return, but I will use else if and else. So, in this case I will say else if, else if position is equals to 0. In that case cout, not cout, but do insert at head and take the value right there. Understood? Later on else, our main code will be written here. What is our main code? We start by creating the temp is equals to, you start from the head, while you are saying minus pos minus position, you are saying temp is equals to temp of next. Keep on doing this, and once you reach at that particular position, what you need to do is you need to say temp of next or n of next, n of next, n of, we have not created the n, no. So, let us create the n right above here. So, node star n is equals to new node, and here we will pass the value. Okay. So, here I will say now n of next is equals to the temp of next, which secures the node first, as I have already explained you. Okay. The second half of the node is captured first, and then the temp of next will be equals to n itself, and there you go, you have done inserted at position. But there is one issue with this, and that is that this size, we have not defined the size anywhere. So, let us do one thing, just above here we will create a int get size, which is gonna not take anything, but I am gonna create one variable int size inside here, which will be later on returned. So, int return size. Here we start by creating the temp is equals to start from the head, and while the temp does not reach equals to null, keep on doing temp is equals to temp of next, and at the same time keep on doing size plus plus. Understood? And then once you reach there, we are going to return the size, which will be called right here. Okay. Before I get anything, I would just create the size variable here, and I will call this get size function, and I will not pass anything, of course. Understood? This is finally the function which we were looking for. If you have not understood the code, let me explain you this very quickly. What I have done is I have started by creating the node itself, and then I have taken up the size variable, where I am getting the size from this function. If you talk about this function I have creating the size, and I am saying equals to 0 to initialize it to 0 first, and then I am saying that temp you start from the head, while the temp does not becomes null, keep on doing temp is equals to temp of next, which means keep on moving it. Correct. Temp of next, sorry, temp is not equals to null means the whole linked list you will travel and keep on traveling, and every time you travel it, you do what? You increment the size, and once you increment the size, what happens is that return that particular size. Okay. Then that size is gonna be returned here, and the position will be checked if the position is valid or not. If the position is lesser than 0 means it is negative, or if the position is greater than the size, which is of course invalid, you will say invalid position in that case. I hope so that this is very much clear. Invalid position. If the position is set to be equals to 0, in that case you will just do insert at head. It's very simple. You will directly do insert at head and you will pass the val. Easy. Else you will say temp, create the temp while it reaches at the particular position. By decrementing the position and incrementing the temp, you said that n of next should take the value from the temp of next, and then temp of next is equals to n, single equals to n, which connects or reconnects everything at once. This is your insert at position fully completed with the help of a helper function called as getSize, which is nothing doing, just returning the size of the particular linked list that we are working with. I hope so that this is very much clear. Let's do some checks if it works or not. See out. This is gonna be the insert at position checks. Check. Okay. So I'll say ll dot insert at position, and I pass 500 at a position 3. At a position 3. Then what I will do is ll dot display. Correct? Let's run this code and check if it works or not. See, insert at position check. So you can see that our program is absolutely correct. As you can see, I said, what was the position? The position was 3. As you can see, position is 3 and this is 500. The value is 500, correct? Understood? So when I run this program, you see here insert at position check. Here first on 0th index we have 60, then on first index we have 50, then 40 on second index, and then third index we have 500. Insert at position is officially over, guys, and we have understood this really well. I hope so that you don't have any doubts into this. If you have any doubts, please do let me know so that I'll get to know where it's happening. Okay, I'll try to help you out with that doubt that you have. Please do let me know in the comment section below, and that's all for today's class. I hope so that you have understood this really well. Before I go, let us say insert this at 0. In that case, 500 is also inserted at a particular position which is 0 in this case. That means the code works absolutely fine and there is no issue. For position being equals to 0, let us check one more condition. If I give the wrong condition, meaning I give 50 as the position, it should say invalid position. It just said invalid position, inserted position check, invalid position. But it just printed the linked list as it is, it did not do anything though. Understood this? I hope so that this is absolutely correct and you have understood this really well. If you have any doubts, please do let me know. I'll try to clear your doubts as much as possible. Well, that's it for today's live session, guys. If you have liked our live, please do like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also. And don't forget to understand this and revise this later on. If you have missed any of the DSA live sessions or C++, in fact C++ live sessions also, please go ahead onto our channel, and there you will see in the playlist option we have recorded live sessions for both C++, OOPS or object oriented programming concepts, as well as DSA live session. This was the 11th live session, and so far we have almost finished up our first linked list concept. Now, because already we are continuing this linked list concept from 4-5 days, I would not waste much time into this, and I would just try to finish this as much as fast as possible. In tomorrow's class, we will be doing the deletion part of the linked list, of the single linked list, finishing up the single linked list concept clearly. Once our single linked list is over, we will find the W link list very easy, and we'll soon finish. I'll try to finish W link list also by the end of this week. Well, thank you so much for watching, guys. This is Ashank David. I'll be signing off now, but I hope so that you have understood this really well. If you have any doubts, please do let me know, and I'll try to clear your doubt as much as possible. Well, anything apart from DSA or C++, please do let us know, and we will try to create the videos or come live as frequently as possible, and we will try to help you out with your doubts or anything with this. Okay. Apart from this, also we have, as I have told you in the beginning, that we are also providing placements as well. So if you are interested in getting placement, or if you're thinking you have not got placed, if you are looking for a better company, you please let us know, because we also are hiring as well in terms of the other companies. We have opportunities related to other companies also. So if you are worried about your placements, if you think that you can crack a company but you're not getting chance, please do let us know. We will try to help you as much as possible, because we have also started the placement wing, where we are trying to get a lot of companies visit, and yeah, we can do recommendations also. So well, that's all for this video and live stream, guys. Thank you so much for watching, and any doubts or any comments, you know how to reach to me, and I'll try to resolve all your doubts, and whatever is it, the link of this notebook will be given in the description below. And well, that's it, guys. Thank you so much for watching. This is Ashank David. I'll be signing off. I'll see you guys tomorrow also at the same time, 6 p.m. 2 live sessions, one at 4 p.m. and one is 6 p.m. 4 p.m. is the C++ OOPS concept, and 6 p.m. as usual, the same thing, DSA live session will be going on. That's all. Thank you so much. Have a nice day. Have a good night. And that's all for this live session. I'll be signing off, guys, and I'll be closing this off.